Okay, so here we have a rocket going up, television camera watching it 2,000 feet away. Television camera at ground level 2,000 feet away from the launching pad of a space rocket that is taken off vertically as seen in the above figure. Write an equation, left side, right side, equal sign in the middle, relating theta and x only, and find a rate. Okay, so let's do it. The formal steps that we're supposed, let me just show this. So step one is find the rate letters, right? We're supposed to find the letters right. So let me just show you how to do that. So as you read through, you go, okay, 2000, no, that's not, nothing to change, that's just 2000 feet, that's not changing. Da 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 da. Let's just gonna find the rate of change of the angle. Okay, so they're gonna eventually speak of the rate of change of the angle theta. When the rocket is rising 1366 feet per second, that's x, huh? That's how x is changing. Want to know d theta dt? We're going to be given dx dt is rising, positive 13. So rising means it's increasing, positive, going up. So step one, identify the rate letters. Did that. Step two, write an equation that relates only those letters. So write an equation that relates only what letters? Only theta and x. Well, that's going to be trig, huh? Theta and x. So how do you know which one? Well, remember the SOHCAHTOA. Remember from trigonometry? Got to know your trig in calculus. SOHCAHTOA. So this side here is the opposite. Here's the right angle. So this side is the hypotenuse, and this is the adjacent. You remember all that? How that works? Oops, let me put in the right angle again. So you know the side opposite the angle theta. And then side across from the right angle is hypotenuse. This must be adjacent. Okay, so we're looking at x and the 2000. That's what? Opposite and adjacent. Which trig function uses opposite and adjacent? Tangent. Tangent is opposite and adjacent. So we got, that's our baby. So tangent of theta is x over 2000. That's opposite over adjacent, opposite x, adjacent 2000. That's how they got this. Okay, and now that's step two, write an equation. And then step three is do the d dt of both sides. So you got to take, let me bring it, well, I can just do it here. So I'm going to go d dt of tangent theta, and I'm going to go d dt. Now, I don't like x in fractions, right? So what we can do, we're going to make this 1 over 2000 times x, right? That's the same thing. And that way, x is not involved in a fraction. You don't want x involved in a fraction. Why? Because if it is, you got to do the quotient rule. And we hate the quotient rule. We try to avoid it anytime we can. So just make this 1 over 2000 times plain x. All right, d dt of both sides. What do we got? What's the root of tangent? Secant squared. Theta times chain rule d theta dt. Why? Because t is different than theta or x. Even x, we're going to have to do chain rule. Why? Because the bottom's dt. Only when the bottom is the same as the letter can you avoid the chain rule, because then that'd be dx over dx, and that's just one, it's gone. But dt on the bottom, that's different. So chain rule for everybody, because everybody's different than t. So what do we got here? So it's going to be 1 over 2000 dx dt. All right. So, what do we do now? Well, we're trying to find, what do they ask us for? Find the rate of change of the angle, d theta dt. Want to find d theta dt. Okay, how are we going to do that? Let me bring this down and down. Well, remember that secant squared is 1 over cosine squared. So, and I think I know, well, let's just leave it like this for the moment. Okay. Yeah, do you remember that? Do you remember that from your trig? You get the sine, cosine, tangent, and you flip them. Remember, flip, flip, flip. It's cosecant, secant, cotan. That's a flip and a flip and a flip. So cosine is the flip of secant. So secant squared is 1 over cosine squared. So we're trying to solve for this bad boy right here, d theta dt. That's what they're asking us for, right? So we're trying to find. That's what they said. Find the rate change of the angle. So how are we going to do that? Going to multiply both sides by cosine squared theta over 1. Cancels out. Same thing here. In fact, I'll just stick it on the top. That's okay. So let's multiply both sides by cosine squared. So, all right. So now we're getting close. D theta dt equals. Okay, now got my 2000 here. Now what's the angle theta? What is the angle theta? How are we going to figure that out? Or what's the cosine of theta? How about that? Well, notice they gave us one other piece of helpful information right here. Rocket is rising at 1366. Oh no, and it's 5370 feet apart. The cam and it's the rocket is rising at 1366. Yeah, we got that feet per second. That's how fast it's rising. And the camera and the rocket are 5370 feet apart. So from the camera to the rocket, they're telling me this is 5370. Do you see that? From there to there. From the rocket, from the camera to the rocket, 5370. Okay, so what? Well, cosine, which is what I need right here, is what? Adjacent over hypotenuse. Cosine of theta, therefore, is going to be 2000 over the hypotenuse, 5370. Adjacent over hypotenuse. Do you see that? Remember SOHCAHTOA, cosine's adjacent over hypotenuse. Adjacent I already had. They gave me the hypotenuse, 5370, right there when they told me how far away we want to know the rate when the camera and rocket are 5370 feet apart. That's the hypotenuse. So that's cosine theta. And I already have dx dt right here at 1366. Let's just put these things into place. This is going to be 1366. And then cosine squared, that's going to be up here, 2000. And careful, it's squared, right? Cosine squared. See what I did there? I found cosine, put it here, cosine squared. There's dx dt, and there's the 2000 on the bottom. I think it's Desmos time. Let's go to it. 2000 over 5370 squared. 2000 over 5370 squared. So 2000 over 5370. Wait, where's the square? I forgot so quick. Oh, yeah, the whole thing is squared. All right, that's too bad. All right, try this again. 2000 over 5370 squared. All right, now we're in business. Over 2000 times 1366. Over 2000 times 1366. 2000 times 1366. Boom, 0.0947. That's a beautiful number. 0.0947. Well, I mean, it's just beautiful because it's right. There we go. We got it. We got the rate of change. That angle, as the rocket goes up, that angle's going up 0.09 radians. And I was in radian mode, by the way. Remember, you got to be in radian mode. Just my Desmos was in radian mode. That many radians per second. It's going up. And there we go.